Let's start by picking up where we left off in the first part by doing an example of joint probability. This example is a little bit different because here we're using set notation, and this question, basically what we have to find is the joint probability of both set A and B. What that means is we have to find the numbers that are shared amongst both sets. So if we look set A and B, share the numbers 3, 5, 7, and 9. So if I were to write this, I would write this in between heart brackets, 3, comma 5, comma 7, comma 9. So this is the joint probability of both set A and B in set notation. Now let's go over an example using Venn diagrams. The problem says the following. What is the probability of a student taking Spanish, chemistry, and math? First of all, we have to sum the total amount of students who have taken the survey. So if we add all these numbers together, we would get that 260 students took this survey. Now I want to find the intersection of these three circles. So the students that have taken Spanish, chemistry, and math class, their intersection are going to be these 15 students in the middle that have taken all three of these classes. So then the probability of a student taking Spanish, chemistry, and math is going to be 15 over 260. And that fraction simplifies to 3 over 52. So this is going to be the probability of a student taking Spanish, chemistry, and math. Now let's put everything that we have learned together. The problem says the following. Find the probability that a randomly chosen person, A, has a red car. So first, I'm measuring how many of these total cars are red. So my favorable outcome is that it is a red car. The total amount of red cars are 181 divided by 456 because those are the total amount of cars that were studied in this experiment. And 181 divided by 456 is approximately 0.40. B, has a speeding ticket. So I want to see the amount of cars that have a speeding ticket. That is my favorable outcome, the outcome that I'm measuring, divided by the total amount of cars that are being studied. So this is going to be 245 divided by 456. So 245 divided by 456, that is approximately 0.54. C, has a speeding ticket given that they have a red car. So we're only going to look at this sample space, the cars that are red, because we already know that this is a red car. So out of the total of 181 cars that we're looking at, what we want to measure is that they have a speeding ticket. So only 89 out of these 181 cars have a speeding ticket. So 89 divided by 181, that is approximately 0.49. D, has a red car given that they have a speeding ticket. So now we're looking at the sample space of cars that have a speeding ticket. So we're looking at this here specifically. So I want to find a car that is red. So the total amount of red cars in this space is going to be 89 divided by 245. So 89 divided by 245, that is approximately 0.36. Now let's go to E. Has a red car and got a speeding ticket. So now we're talking about joint probability. So here, if we look at our table, we want to find where having a red car meets with having a speeding ticket. So 89 out of all of these cars that were measured were red and have a speeding ticket. And F, has a red car or got a speeding ticket. So now we're talking about union probability. So the probability that it is a red car, we already had it here at the top. We would have 181 over 456 plus the probability of having a speeding ticket, that is going to be 245 over 456 minus the probability of both. So if we look at our table, the intersection of having a speeding ticket and the car being red is 89 out of 456. So if we input that in our calculator and we evaluate that, we would have 337 over 456. 337 divided by 456, that is approximately 0.74. So the probability of it being a red car or having a speeding ticket is going to be 0.74. In conclusion, probability helps us determine if an event is likely to happen or not. Probability is applied in various subjects and used in various different fields, from weather forecasting, sports betting, blood typing, and it's applied in many more fields of biology. Thank you so much for watching.